Given the initial velocity vector as 2 I cap plus 5 j cap and the acceleration as 2 I cap minus j cap, find the position vector at t is equal to 2 seconds. Oh yeah, and also draw a diagram to illustrate the motion. Okay. So we have a bit of things to write and analyze. So the particle has an initial velocity. Already it's moving with a particular velocity. And someone happened to push it. And it accelerated. And it's still accelerating, I guess. Yeah, it accelerates basically with this. So we need to figure out where the particle is at t is equal to 2 seconds. So what do we do? Simple. We'll make use of position vector is given by, so we don't know r naught, so we'll just consider it to be 0. So we have u t plus half a, okay, this is not a function of time, t square. Oh, ut by the way, this is function of time and also t. Right? So this is quite simple again. As you can see, just the same formula, just that we are using arrows and stuff like that. 2 plus half of acceleration is something. I'll write 4 over here, that's time square. And this is 2 I cap minus 1 j cap. This is 1s are 2s are. So this would be 4 I cap plus 10 j cap plus 4 I cap minus 2 j cap. So this is 8 I cap minus 8, oh sorry, plus 8 j cap. So this is where the particle is. Also draw a diagram to illustrate the motion. Okay, so this is a two-dimensional motion. Right? So we have minus also, na? No, both are plus. Okay. I can just go with this. Is that 8? The particle was initially at 0. So this is where the particle is. That's what we are assuming. So R naught is 0. Then we have 8 I cap. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So this is where it ended up at. But in between it was, okay, so in between where was it? We'll figure out, this is at 2. I just want to figure out where it was at 1 actually. So R at 1. So we have 2I plus 5j. Since we have to trace the motion, we have to figure out at each point. So this is, wait, half of, this is half itself. So this is I cap minus j cap by 2. Again, you do the math, you'll get the same thing. 3 I cap, then plus 4.5 j cap. Okay, I think I did the math right. Ut is 1. So this will remain the same. This will be 1 by 2. Wait, acceleration is this. Perfect. 2 by 2 is 1. Yeah, correct. The particle is basically after 1 second. It is 1, 2, 3. 3, right? And 4, 1, 2, 3, 4 point this. So this is at 1 second. And this is at 2 seconds. So basically the particle is moving something like this. Okay, guys. So that's your X and Y axis. And yeah. Okay. So what we looked at, what we did was we figure out where the particle is at 2 seconds, right? So R of 2 basically. This is R as a function of, oh, my bad. This is R as a function of time. This is R of 2. Then we trace how the particle is moving as well by finding R of 1. So this is your kind of motion diagram. Per second, an object following this particular acceleration and this initial velocity, starting off from the origin.